Looks like we're live. Hello everyone and welcome to yet another Azodin session. So let's make a little bit of an announcement and officially... Oh no! Your server is going to lose level! Refer to your server settings for status details. Anyway, so let's do a little bit of an announcement. Red Circle live on Twitch. And what are we doing today on Twitch.television? Today we're programming a 3D graphics and C. That's what we're doing today. So let me give you the link to the Twitch channel where we're doing all of these shenanigans forbidden by Geneva Convention. And the stream has been officially started. There we go. So yeah, so today we're going to continue developing Olivets, which is a simple library in C that we've been developing for quite some time. So it's a very simple library that doesn't have any third-party dependencies and renders everything into the memory. So essentially you allocate a memory and it will just put some pixels in there, and it's up to you how you interpret those pixels. You can put them on the screen, you can save them as a file, you can maybe do animation, right? You can just maybe fill up the buffer of pixels every frame and those make animation. It's all up to you. This thing is just a huge mem set or mem copy, whatever you want it to be, right? So just like manipulates the pixels. And the things you can do by manipulating pixels is are present in this website. So you can draw triangles with a gradient, right? The classical rainbow triangle. You can have transparency. You can have 3D. Well, I mean, the 3D is not, you know, so to speak, not an intrinsic feature of the library yet, but here we're using like a simple projection of a point in 3D space onto the 2D screen, and that creates this effect. This is nothing particularly special. This is nothing particularly special. And you can manipulate the textures and stuff like that, and you can even do a little bit of a 3D with Z buffering, and we implemented that recently, actually. Right. And another thing that we implemented recently is rotating texture, but the way we rotate texture is basically we take this quad and we split it into triangles, right? And we render textures on those triangles, right? So actually here, instead of a single quad, we have two triangles in here, right? So the latest feature that we implemented is rendering textures on a triangle. And here is the next logical step. Today we're going to try to combine these two demos together. How do you speak English? I don't know. So we can render textures on the triangles in 2D. We can render 3D triangles with Z buffering. Can we render 3D triangles with textures? That's an interesting question. Right, let's find out. So this is basically what we're gonna do today. So it shouldn't be that much of a difficult topic, the famous last words. So maybe after that we're gonna do some other minor things. But yeah, so today we're gonna try to do a 3D textures. So we have a couple of subscriptions. Thank you so much, Basil Loves Plants, with a comment. And Lego Megar R, thank you so much for gifting sub, for continuing gifting sub. Thank you. So yes, hello, welcome everyone. So you can find the source code of this library if you're interested in here, of course, right in the description if you're watching on YouTube. And let's go. So let me fetch the latest stuff. I think I already have everything fetched, so should be fine. And let me get clean and rebuild everything just in case, because who knows what's gonna happen. Alright, so I'm gonna do build. We have a lot of shit to build because we have a lot of different examples, different demos and stuff like that. So yeah, as you can see, we're building all of the demos. That's a lot of them actually, and this is because we have like a combinatorial explosion when it comes to demos, because for each demo we build it in 3 ways, right? We build it for SDL, right, and then you can just take something like triangle 3D and run it as SDL. Right, so this is SDL native application that is doing 3D without OpenGL, by the way. There's no OpenGL. The third one is a WebAssembly, basically on the website that we saw recently, right? so down below. So this is a WebAssembly version, and there's another one which is called the terminal version, which renders in the terminal, believe it or not. So essentially it takes the pixels and it converts them to characters to make it look like it's rendering in the terminal. So that's what we're doing here. So let me actually open it up. So triangle 3D terminal, and this is how it looks like. This is the same application, but it's rendered in the terminal, right? It is rendered in the terminal. Isn't it Poug? Isn't it Poug, fellow kids? I think it's pretty Poug. So let's go ahead and just grab the 3D triangle, right? And maybe even copy paste it. So I'm gonna call it triangle 3D tech, right? Tech. Something like that. So we have triangle 3D, then we have triangle tech, and then we have a triangle 3D tech. So there's a little bit of inconsistency in naming. So here I'm using camel case and here I'm using snake case. Maybe I'm going to quickly just do something like this. Boom. But that will require me changing that in all of the places where I was mentioning it like that. So you know what I'm going to do? I'm going to query replace triangle tech with triangle tech like so. And I'm going to keep searching for triangle underscore tech. And every time I encounter it, I just do it like that. Then another one, triangle underscore tech. And that was the last one. Yeah, there we go. So now we have sort of like different variants. We have just a triangle. We have a triangle 3D. We have a triangle texture and a triangle 3D texture. So this one is supposed to be a C file. Let me quickly call it C file. There we go. So maybe we also need to add it to the build, right? And here we're gonna have 3D tech. So as you can see, as of right now, we are building 6 different demos, and each demo is built in 3 ways, right? So let's actually build everything. So maybe I'll have to separate the building of the demos somehow, because there's a lot of them, and quite often I don't really want to build all of them, right? Because I don't really care. Because I do not really care. Okay, so cool. So maybe I'm gonna go just like to build a sage. I'm not sure if I need assets. I can build assets, why not? And I'm not gonna build the tests, and I'm only gonna build the 3D tech. And for now, I don't think I care about the terminal, and I don't think I care about WASM, right? So we're only going to be building 3D tech and only for the SDL platform. I think it should be fast because of that. It should be relatively fast. Okay, so and if we run this thing afterwards, triangle 3D tech, SDL, so what we're going to have. So here it is. So to test how the current texturing works in 3D, let's actually try to get rid of one of the triangles, right? So let's try to do the 3D of the texture without the Z buffering, right? Let's actually get rid of one of the variables, so get rid of the Z buffering, right? So which is kind of interesting. So when you render textures in 3D, you have to take into account 2 things. You have to take into account the perspective, right? So how you project it on the screen, and you also have to take into account the depth, the Z buffer, right? Because you can have several rectangles that intersect each other, they overlap with each other and stuff like that, so it can get complicated. So let's get rid of one of the variables and make our lives a little bit easier, because it's already harder as it is, right? So why making our lives more harder than it should be, right? Okay, so what do we do here? So we have this thing and then Z buffer, and then here is the second one, and then we merge them together, I suppose, which is fair enough. So I don't render the second thing, so maybe I'm gonna actually use the you know, the preprocessor to comment it out. So if you do if 0, if it's effectively everything between if 0 and if is going to be commented out, right? So it's a sort of like a very huge comment, and you may ask, why the fuck you not use something like this, right? Which is also a block comment in C. Well, this kind of commenting of the code allows you to flip-flop. You basically can enable the block of code, or you can instantly disable it. It's that easy, right? So we have a huge code of block, and you can just with one change enable it, test something and disable it. Quite convenient, right? So the regular block comments cannot really do that, right? So to enable this block of comments, you will have to go to the beginning and to the end to remove them and stuff like that, and then you lose the boundaries of the block. Here the boundaries of the block are always the same, you just like flip-flop between them. So I suppose if you programmed in C and C++ long enough, you kind of know about this trick, about like commenting out like a huge chunk of code quickly and back and forth, right? It's a very useful thing. And at some point you may realize, okay, so this block of code may be some sort of a feature, and you can put it behind like a feature flag and enable, disable it through the command line, right? So because in the command line you can do something like gcc feature flag, right? So yeah. So, but I mean, you'll have to use if-def in that case, not just if, but you get the idea. So, that's actually very common among C++ developers to comment out the block of code like that. Alright. Anyways, so, yeah, we basically render everything in here. We also render the Z stuff, and maybe I'm gonna just keep the Z buffer as it is right now. I don't think it's that important, so anyway, let's actually just go ahead and build everything, and there we go. We have a single triangle. Isn't that cool? Isn't that cool? I think it's pretty fucking cool. I think it's pretty fucking awesome, mate. Fucking awesome. So, essentially, we probably want to just like take a texture and put it in here. So if I comment out the Z buffer, so it will probably tell me that I have some things in here that I should not have. Fast Magic 47, thank you so much for 4 months of tier 1 subscription. Good evening, good evening to you too. Добрый вечер. Alright, so let me see. It's based on OpenGL? No, it is not based on OpenGL. I actually rendered this thing pixel by pixel in a buffer. That's right. That's right. So we can even take a look at the Olivet's Triangle 3C, the implementation of this entire thing. Let me actually go and just see. So here's the implementation, right? So we take 3 points and 3 colors. We sort the points, right? Because we're gonna be rendering it in scanline. And then we are just iterating through the scan lines of the triangle, right? So like so, using bare standing coordinates, we are interpolating the colors, and we do that for the bottom half of the triangle as well. So as you can see, no OpenGL, we just render everything on CPU, pixel by pixel. All right, so one of the things I want to see, right? So I need to have a triangle 3 tag. Is it called tag, or is it called something? I think it's called, yeah, it's called UV. That's quite important. There you go. So this one accepts not only the corners, angles, corners. I don't remember what's the difference between corner and angle. So the thing is that in my native language there's no difference between corner and angle. So what's the whatever. So essentially you take the 3 points of the triangle and then the UV coordinates and then the texture that you want to put on the triangle. I'm sorry, I don't speak English at all. It's not my language. So I'm just pretending that I speak English. In fact, I do not speak English at all, like at all. Right. Corner you're looking for. Okay, thank you. Corner of triangle. 3 corners. Wait a freaking second. What kind of hypocrisy is... Wait a freaking second. If the corner of the triangle is called corner, why is this mother flipper called fucking angle? What kind of hypocrisy is that? I'm so fucking mad. Like, the fuck? I'm sorry. Welcome to English. I have a feeling, I have a suspicion that at some point in English, angle and corner were also kind of the same thing, and maybe at some point they diverged, and that's why triangle is still called triangle, because I have a feeling that triangle is like a very old word, and maybe coming from a very old English, where angle kind of had the same meaning as corner, right? As it is in many Slavic languages, by the way. So that's actually a very interesting thought, but this is just my hypothesis. I'm not a linguist, so I don't know shit. So yeah, it must be an old word. Tricorner, yeah. We should call it tricorner. Oh, it's also in European languages as well, right? Like that. There's no really difference between corner and angle. Yeah, I see. So English just decided to you know, be distinct in that sense. Anyway, so let's do OC1, and we have to provide the corners. I keep forgetting the word. Alright, so these are the corners. These are the corners. There we go. But we need to also decide on the corners of the texture, right? So we need to decide on the corners of the texture, and I'm thinking that at the bottom one is going to be... So if we think about it this way, right? So this is 0, and then comes U, and then comes another one, like so, V. It's actually kind of funny. It's like V also here acts like an arrow. Okay. So anyway, so here is that, and let's put it this way. So it's a 1-1. So that means that in terms of UV, although that's UV, the first one is going to be 0, 1. So I want to take this point, right? So this one, like so. Let's put it this one. Right, so the next one is going to be in the middle in here, right? So that means it's going to be Olivet's UV, and it's going to be half, and then 0. Okay, so then... So again, this is another, you know, sort of like hint that we're not using OpenGL, because we're using like a classical screen coordinates where y goes down. In OpenGL, y would usually go up, but here, as you can see, we're not using OpenGL. That's why the coordinates are slightly different. Even though we're kind of reasoning in terms of like OpenGL-ish concept, right? UV coordinates, like textures and triangles, percentage coordinates and stuff like that. So yeah, something like this. Okay, so these are the coordinates. These will form a triangle within the texture, and it will just cut the corner out of the cut the triangle out of the texture. So the next thing we need to do, we need to come up with the texture. So we're going to be using probably the classical Pogue texture that we have in here. So it's going to be 23, and I'm going to just put it in here. Let's put it somewhere here. There we go. So this is going to be a sodium Pogue. Right. So let me try to compile this entire shit and see how it's gonna go. Alright, so we don't have sodium pixels and stuff like that, and this is because we have to include that image into the C code, right? Which is rather interesting. Like, how do you include an image into the C code? Well, you have to compile it to C, and that's exactly what we do. We have an image, sodium Pogue, compiled to C, which is kind of funny. So these are the pixels of the image, and we compiled it from the this image, right? So this is essentially this image, but compiled to C. Can your JavaScript do that? Can you, in JavaScript, take an image and compile it into JavaScript, include into the JavaScript, so you can save the traffic on your web? What the fuck am I saying? You can't do that. JavaScript is shit. So program in C. So let me try to recompile this entire shit. So I also have to include this entire thing. So right, so include assets, sodium Pogue, .c. There we go. Cool. But can your JS segfault? That's actually a good question. Let me actually try. New uint 8 array, right? And then I can get 0. Oh, or how do you get this thing? Does anybody remember? I think you just do that. Yeah, there we go. So that's how a segfault in JavaScript looks like. Because I can tell you a small secret. When you program in JavaScript, you treat memory as basically an 8 array, especially when you're interacting with WebAssembly. So this is basically dereferencing null points in JavaScript. Kind of. Kind of. Anyway. Well, I mean, I can even show you, like, we're compiling our applications, our demos, to WebAssembly. So we have a JavaScript runtime. There we go. And so when we're reading from the memory, right, we take a memory buffer and we actually treat it as uint32, but it just depends on how you want to treat it. And yeah, that's basically how we do all of that. So here we actually like parsing a structure. Yo, this is so cool. I forgot I did that. Yo, this is so cool. This is a structure, C structure definition. This is a C structure definition, and this is a function that reads a C structure from the WebAssembly memory in JavaScript. What the fuck? This is so cool. I forgot that I did that. Holy fuck. Oh shit, I even put it to do myself. Nothing in this kind of declaration states that iota measure units in U and yeah, so basically here I have like some sort of automatic alignment and automatic size of the structure calculation. Yo, that is so fucking cool. Holy shit. Who needs C? Program in JavaScript. C is fucking old as fuck. Look at all this cool shit you can do in JavaScript. Do you have a wait and a sync in your stupid C? I don't fucking think so. Right. Anyway, so let's continue. What I was doing. Yeah, okay. So I already implemented the rendering of the triangle, so let me see if this entire thing compiles. Right, so it's going to be build.sh. And the moment of truth. Right, so we took the 3D rotating triangle, right? 3D rotated triangle, and it was basically the gradientish rainbowish, right? So we tried to render it with a texture. Will that shit work? That's the most important question. Will that shit work? So let's go ahead and just like run it and see, and let's take a look at the results. Triangle, 3D tech, SDL. It won't work. Can your JavaScript do that? I don't fucking think so. All right. So I forgot how we do that. So I think maybe one of the things we have to do is not use like equal to 1 or something like that. So let me double check how exactly I rendered the texture in here. Right. So here's the texture, right? So in Pogue. So this is example that just renders the texture, right? And then we use it in here. So we have UVs like so. And here we just use like 0, 1, 1, 0, 0, 1. So everything seems to be fine. So should be okay. I don't see any problems. And nothing really overflows in here either. But it actually tried to do something, right? So one of the things we can try to do, that in GDB. And GDB will tell us where exactly it failed. Right, so triangle tech, 3D tech, what is it called? SDL, there we go. So let's just try to run it, and boom. And what do we have in here? So it's segfaulted, and it's segfaulted where? Right, it's segfaulted precisely at 8.5. Olivets 805, right? So it couldn't take the pixel, I suppose, and the question is which one it couldn't take. Which one it couldn't take? Couldn't take this one or this one? That's a good question. So let me see if I can print some of those. Can I print X in here? Okay, so X seems to be working, and Y. Okay. But I don't quite remember what is the size of OC. Can I print OC? Okay, so OC seems to be reasonable, so it's a width. All of these values are less, so that means we don't have a segmentation fold in here. So let's take a look at the next texture, texture X, right? So and texture Y, and texture Y is optimized out. Okay, so if we take a look at the texture now, and texture is optimized out. All right. So let me see, that's kind of interesting. So it was optimized out, but I suspect there's something wrong in here. Oh, here's an interesting thing. Maybe we should like explicitly clamp the textures. Right, you know, when you work with OpenGL, there is a thing where you can choose a strategy on how you clamp your texture coordinates if you overflow. Right, so the question is, why can't we do it in here as well? So basically what we did here, we essentially we found a bug. This is a bug within the library, so it allows you easily just accidentally overflow the textures and access the members. So this is something that we have to literally handle, I think. I think it's quite important. So we can say if texture X is less than 0, that means it has to be equal to 0, right? And if it's greater or equal to texture width, right? Texture width. If it's equal to texture width, we have to make it equal to texture -1, texture width -1. So, and we have to repeat all of that shit for the Y as well. There we go. So width and height. There we go. So when we have to repeat this entire thing for the bottom part as well. So I'm gonna put it in here. All right. All right. Look at that. There's something, and it's still actually segfaulted, which is rather interesting. Greetings from Novosibirsk. Yeah. Is that because I didn't recompile? I remember that I tried to recompile. Right, so let's actually do recompilation one more time. Ooh, it didn't even compile properly. All right. Use event declare, did you mean... Oh, it's a texture width. So that's why it didn't fix, because I didn't recompile my shit. Okay, so that explains. And why did it work for so long then? I don't fucking know. Okay. Ooh, right, there we go. So we have some weird thing. So we have unsigned comparison. What's interesting is that I know that at this particular point X is not going to be negative, so I can quite safely cast it to size T. So, and that's precisely what I'm going to do in here to get rid of the warning, right? Those pesky warnings. So, hello, do you know how I can learn graphics programming either with C or C++? First of all, you have to know C or C++. Right? You have to know these languages, right? And know them relatively well, right? So you have to be comfortable with them. The next thing you have to do, you have to know geometry. Sorry, you have to know geometry. And third thing, you better know linear algebra. So, there you go. Here's the roadmap. Okay, so let's actually go ahead and just try to do that. And it is working, it is working. Look at that. So there's something rather weird with this entire thing. It kind of works, don't get me wrong, but I think, yeah, it's kind of like is all over the place. I think it's like shifting. It feels like it's like shifting around, if you know what I mean. The rotation is a bit dang. And as far as I know, this is because we do not take into account projection. Right, we do not take into account projection. Because essentially what we do, we interpolate the texture coordinates linearly across the entire triangle. Right, but the points on the triangle, when they're projected on the screen, they're not interpolated linearly the same way as the z values of each individual pixel of the triangle are not interpolated linearly, and that's why when we did z buffering, right, when we did z buffering to make these two triangles intersect, we actually had to interpolate 1 over z, 1 divided by z, because on the screen, when the projection has happened, 1 over z interpolates linearly, not the z itself. Z is not interpolated linearly. So, as far as I know in here, what we have to do, instead of interpolating UV, right, we have to interpolate UV divided by z. Yes, UV divided by z. And then when we need to get the certain pixel of the texture, we need to multiply it by z to get it back, and then do the thing that we're supposed to do. So we get the idea. Right, so let's actually try to do that and see and compare the results, right? And compare the results and see if it's actually make any freaking difference. So let's try to interpolate 1 over z. So essentially, we also need to... Oh yeah, there we go. So here are the z values, right? v1z, v2z, v3z. And we can literally just try to do v1z. imagine dividing 0 by anything. But I mean, I do that for the symmetry, just to indicate that the entire thing is sort of divided by z. I could have done it something like this and then overload the division, but I'm programming in pure C. You don't have operator overloading in pure C, so that's why you have to kind of do it like that. But it is what it is. So, and I'm gonna just like put it like this. Okay. Alright. Cool. Holy triangle of something finally appeared on the screen. I mean, we're not programming in OpenGL. We always have something on the screen. And sometimes segfault as well. Alright. So, okay. So here's an interesting thing. I divided this thing by z. But when I'm accessing the texture coordinates within the triangle 3UV, I'm not multiplying this thing by z back. So this is something that I have to do inside of the implementation, which means that I'll probably have to create a separate function UVZ, or maybe replace the current one with UVZ. And if you don't want to use z, basically you set all of the z coordinates with 1, right? In that case, it's assumed that all of these things are divided by 1 and they're going to be pre-multiplied by 1 as well, so it's sort of like cancelled out. Yeah, so I think we will have to extend this function to accept the z coordinates as well. That's actually a pretty cool idea. And one of the things I forgot to do, I actually have to use different vertices in here. Wait. Isn't it called vertex? Triangle vertex. That's the word I was looking for. Not the corner, not the angle. Vertex. God damn it, I just realized. Yeah. So this thing should be called tri-vertex. That's right. Not triangle, not tri-corner, tri-vertex. All right. All right. So let's go ahead and try to run this entire thing, right? Let's just try to run this entire thing and see if it changed anything. I think it should change something. It kind of like, yeah. So it actually stretches it out. Look at that. It's kind of funny. Right. So, and this is because, like, yeah, it literally depends on the z of this thing. Right. So to get rid of this like weird effect, we have to multiply it by the z inside of this function, right? Before trying to access those things. So because of that, I think what we have to do, we have to accept the z coordinates as the parameters in here, right? Like so. Yeah. So we need to extend this entire stuff. We need to extend it, so it's gonna be rather interesting. Okay, again. So let's go ahead and open this stuff. Where is my Olive C? Here it is. Triangle 3 UV, triangle 3 UV. All right. So we already have a version of the function that accepts the z coordinates, right? So now here, so this is Olivet's canvas, so this is UV coordinates, and we are accepting the z coordinates as well, right? There we go. Triangle 3 UV. I'm gonna put it in here. So this is a pretty huge signature, right? This is a pretty huge signature. And when we are sorting these things, I also have to sort the z coordinates, right? Might as well. Can I query replace UV with z? Right, but here we have to have a float. So this one is a float. Z6. There we go. Oops, I think I did a oopsie doopsie and potentially fucky wacky because I have to duplicate these things. Yeah, I have to duplicate these things before doing anything with them. There we go. So it's going to be 7, and this is going to be something like this. There we go. Then, before trying to access anything in here, right, UV, I'll have to pre-multiply this stuff by, depends. What should I multiply by? It's... Oh, I should multiply it by interpolation of z. Yeah, I have to also interpolate the z, and then we're gonna multiply it by z. So we're gonna have some sort of a z in here, right? So here is the z, and then we're going to interpolate it, but we already interpolated it before in 3z. Right, so there we go. So that's the interpolation of this thing. There we go. So and we have to do that for the second thing here as well. Right, so this one is going to be z, and this one is going to be z as well. Right. So I'm really looking forward to compare how it's gonna look like. And it didn't do shit! Yay! That's so cool. I'm actually surprised why. Alright, so let me try to do the following thing. Ooh. Oh, yeah, okay. Because we can't interpolate the z's. Because again, the z on the screen is not interpolated linearly. It's not changed linearly. So we have to actually do it like that. We have to do it like this. And here's an interesting thing. Since we divide those values by those already, maybe we don't have to divide them in here, alright, and then just do everything internally. But first I want to actually try as it is already. So we're interpolating z, and in here what we have to do effectively is divide by z, right? So we have to invert it, so to speak. All right, we have to invert it, so to speak. right. Look at that. That's pretty cool, I think. I think it's not stretching around. It's actually perfect, right? It would be kind of cool to compare them, but the question is, how can we compare them? So essentially, where is my 3D text, right? So if we divide everything by 1, and then we'll have to divide, yeah, so essentially what we can do, another interesting trick with if 0 that you maybe heard before or maybe didn't hear before. Essentially, you can also have an else branch, and basically you can have 2 versions of the block of the code, and only one is going to work at a time. For instance, this one is going to be commented out, and this one is going to be active. Then you can flip-flop between them by doing so, right? So now this piece of code is active and this one is disabled. So now I can quite easily just switch between them, right? And see how with taking into account projection and without taking into account projection looks like, if you know what I mean. Right, to achieve that, we're going to be actually getting rid of the division by z, because we're going to assume that all of the z's are equal to 1. All of them are equal to 1. Yeah, so, and then inside of that function, they are effectively going to be divided by 1, but that's not going to change anything. If you divide something by 1, it's going to be the same thing. Okay, so here we're not taking into account projection. So let's take a look at how it's going to look like. All right, so you know what? I'm going to actually copy paste it. I'm going to copy paste the executable 3D tech SDL no proj, right? So no proj, so it stays in here, and then I can do something like triangle 3D text SDL no proj, right? So this is no projection. And then I'm gonna go in here and enable take into account projection. Yeah, this is not going. And just gonna rebuild everything. Okay, so here we're taking into account the projection, so I'm going to put it somewhere here, and then triangle 3D text no projection, something like this, and this is without taking into account projection, and this is with taking into account projection. Can you see the difference between them? So the left one sort of like warps a little bit. It slightly warps, it doesn't really feel natural. This one feels natural, it doesn't really morphs or anything. It's just like it's 3D. This is how you would see 3D texture. The left one feels very PS1-esque. It's interesting. Is that because in PS1 they didn't take into account the projection? That's actually very interesting. Yeah. Oh, at all? Okay, that's very interesting. Is that because it was expensive? Because you have to do like an extra division? Because I can imagine that like an extra division on such a machine could be extremely expensive. There wasn't a Z buffer or anything. It's quite interesting. But here's an interesting thing. You don't need a Z buffer in here. We're not using Z buffer in here either right now. So yet we can take into account the projection. So it all comes down to an extra division or extra multiplication, and maybe they were saving on that. This is just my hypothesis. I know nothing about PS1. All right, so that's pretty cool. But as I already said, we don't really do anything in terms of Z buffer, and maybe the time has come to actually try to take into account the Z buffer. And the question is, how we're going to be doing all of that? Well, in the original example, right? In the original example, we rendered all of that into the third thing. All right. Okay. So here we also rendering all of this into the Z buffer, right? So triangle 3Z. So this is UV coordinates and this is 3Z. And then we might as well... Wait a second, I have a feeling that it's gonna just work. Wait. Huh, okay, let's give it a try. It's probably gonna be slow as well. Okay, so something didn't work. ZB1, and this is because I disabled this buffer. Sure. It might be slow because we're doing a lot of like complicated shit. Look at that. Okay. Huh. That was easier than I expected. We also have shading. Have you noticed that we have a little bit of a shading? So yeah. You a musician as well? Yes, I have unfinished musical education. That's so cool. This is not even OpenGL. What the fuck? Oh, this is so cool. I'm so proud of myself. Holy shit. And it just worked. The fuck? Yo. I can now make a 3D engine from scratch, pixel by pixel, without OpenGL. So I had a very old, I have a very old book about making 3D games for Windows. Let me actually find it. Andre, but I don't know how to write his surname properly. I think it was like in Cyrillic. Lamont 3D games. I hope Google is gonna correct me, so I'm really sorry for butchering his name. Almost, yeah. So I think I talked about his book before. 3D, no, yeah, 3D games. Tricks of the 3D games groups. I had this book some time ago. I bought it when I only started to do programming, when I still was in high school. I opened it up back then and I couldn't understand shit. Holy fuck. And a lot of what I do today is actually described in that book, but I never read it properly. So whatever I know in that book, I recently I actually opened it up and I realized that I understand like 99% of the math in there. But back then I couldn't understand it. But now I understand it, and I understood it by not even reading that book. That's what's weird. Everything in that book I already kind of know, but I learned it outside of that book completely. So yeah, and the thing about this book is that at the beginning somewhere in that book, he said that the idea of that book is that you have an environment where you can only put one pixel on the screen, right? And our goal is to write a DOM with that. Like imagine an environment or a library, you can only put one pixel on the screen. Your goal, write a DOM. There you go, and it explains all of the math and everything that is needed to write a DOM if you only can put a single pixel on the screen. So yeah, and this is kind of what this library is about. This is kind of what this library is about. And the way I learned everything is actually throughout the many years of doing like different things and stitching pieces together, because that's how I learn things. Like I can't learn things from reading books, but yeah. So next thing. We need to try to run this thing in a browser. Oh yeah, at some point he switched to electronics. Yeah, I saw that. So he kind of like, did he get tired of the game development? Because it looks like for some time he was like specializing on like game engines and 3D games, and at some point he switched to electronics. So maybe he got tired of it. I don't know. Anyway. So... Alright. Oh, yeah. We need to actually compile everything. So, since I changed the the signature of that function, some of the other demos probably don't work anymore, so we'll have to fix them as well. So let me do that. It sounds like he's interested in too many things at the same time. Oh yeah, I see. Here's an interesting thing about like software development, game development, web development, electronics and stuff like that, is that despite how different all of that sounds, it's actually very much connected to each other. So by doing game development, game design even, web development, electronics, low-level assembly, you're kind of exploring the same universe because all of these things, they're smoothly blend into each other, right? So you're kind of like still interested in a single thing, but in a single big, very big thing, right? So because the hardware electronics like smoothly gets into the assembly, then assembly into C, C gets higher in level, then get into the game engines and the game design, then in art. And yeah, so in some sense you can really connect electronics to like art or 3D arts or something like that, because it all just kind of blends into each other and affects stuff. And here's an interesting thing. Programming abstractions, software abstractions, are extremely leaky, to the point that quite often they leak into the user experience, right? And sometimes the abstractions are so freaking leaky that the user has to be aware of some of the low-level hacks that programmers put into the system. I think a very good example is normal maps, right? Normal maps, as far as I can understand, is pretty much a hack. This is straight up hack to add more, visually more polygons into your model, into your 3D model, right? So essentially you have like a high polygon model, and then you sort of like reduce its resolution, but you add up this resolution back by storing some of the normals of these polygons in the texture. Because in the texture you have a pixel which is 4-dimensional vector, so you can store a vector in there, and you can create a texture which is basically a texture of vectors. And what's funny is that it's a very much technical hack. It is very much technical hack, but it's so intrusive that the artists, the 3D artists, are aware of it. They know what it is, and they know how to generate and work with the normal maps. Why artists, very much non-technical people, have to know of these very much technical hacks. That's how leaky abstractions are. And because of that, all of that stuff, even though you do programming, you kind of go into the art, and from the art you get back into these technical hacks and stuff like that, and all of that is sort of like interplays with each other in a very interesting ways. Right, so you know what I mean? Does it even make any sense? Do I, to like, whatever I say, does it even make any sense? It feels like I'm maybe saying some bullshit, but yeah. So all of that like very much affects each other, and all of that is like part of the same universe, and yeah. Anyway, so I wanted to build this entire thing and see how it works in here. So we have a triangle, but I'll need to add 3D text. So replace triangle text, triangle 3D text. There we go. And here I'm going to also do the same thing. So I'm going to start the server. I guess you get into hacks when you kind of want to do more advanced stuff in most topics. Yeah, I guess. And it depends on the definition. So sometimes hacks are so common that they're not even hacks anymore, right? This is what Epic Games is trying to solve with virtualized geometry, no need for normal maps. Oh, so essentially they are like trying to close that leaky abstraction, right? So people don't have to think about that or something. Wait a second. Why did I use this specific port? I should have used 69 as 69. All right. That's so slow because I'm running all of the demos at once while also streaming. Okay, so what if I don't run all of the demos at once while also streaming? So we can try to do something like this. I'm going to disable some of these things. Yeah, there we go. And now we have that. Look at that. So rotating triangles. It's pretty cool. So it works in WebAssembly as well, in a browser.